Alright, so now inverse trig functions. Much like with trig functions, there's really not a whole lot to talk about with these in terms of concept. Just some reminders here. Inverse trig functions, remember we can label in two ways. We can label them using a little inverse sign for our functions, or arc sign as well. Both stand for our inverse, in which if we know the trig ratio, we can find the angle in radians, of course, because this is calculus and not physics. As far as the derivatives themselves go, I honestly don't know of any easy way of memorizing these. I will say that typically what I do is I remember all the ones without co. So derivative of inverse sine is 1 over radical 1 minus x squared. Derivative of inverse tangent is 1 over 1 plus x squared. Then derivative of inverse secant is the one that's a real pain. It's 1 over the absolute value of x times the square root of x squared minus 1. The co's are all the negatives of these. So inverse cosine derivative is the negative of the derivative of inverse sine, and so on. To go through, inverse sine of x, we want to find its derivative when x is 1/2. So first of all, our derivative for x, because it's inverse sine, would be 1 over square root of 1 minus x squared. Because we want to do this for 1/2, plug in 1/2 for x. So it'd be 1 over the square root of 1 minus the 0.25, which would be 1 over radical 0.75. Example here, inverse sine of x squared. Here the thing to watch is making sure that you're doing your chain rule. So if I want to do my derivative, I need the derivative of sine, which would be 1 over 1 minus, and then I'm squaring what's inside my inverse sine, so it's going to be x squared, which is x to the 4th, then derivative of what's inside, which would be 2x. For the derivative of inverse cotangent of radical x, well, this is the same as the inverse cotangent of x to the 1/2. So for its derivative, because it's a co, I know that there's going to be a negative of 1 plus whatever I'm taking the inverse cotangent of squared. So x to the 1/2 squared was x to the 1st. Then by chain rule, derivative of x to the 1/2 is 1/2 times x to the negative 1/2 power. Then finally our inverse secant. It doesn't have a negative because it's not a co. But this is the one where I have the absolute value of what I'm taking the inverse secant of times the square root of what I'm taking the inverse secant of squared minus 1. And then of course we do have to worry about the chain rule. So times the derivative of x squared, which is 2x. Now, in terms of simplifying, I did want to take a moment here to discuss the absolute value sign, because I can't cancel the x on the top with the 2x with the x squared on the bottom while the absolute value sign is there. However, because x squared is always positive, I don't really need the absolute value sign. So I can drop the absolute value sign since x squared is always positive. And now I can cancel an x on top and bottom, and especially if this were multiple choice, our derivative would just be 2 over x times the square root of x to the 4th minus 1.